Okay, so now what we're going to do is actually put our notes into practice. So the first thing that we know is that DNA damage activates p53. So up here, I'm going to draw my DNA, put a little X through it to indicate damage, and we know that it activates p53. So the arrow indicates activation. We also know that if it's acetylated, so if DNA is acetylated, we're going to put a little A here. So if you need a key, A is acetylated. You can do similar things when you draw phosphate groups for phosphorylation. If it's constantly acetylated, that it upregulates Bax for apoptosis. But we know that p53 is a transcription factor. So it's a transcription factor for Bax, and Bax leads to apoptosis. But we also have this information about low acetylation. So we know that there is an acetylase that adds acetyl groups and a deacetylase that takes them off. So I might say acetyltransferase puts them on, and a deacetylase takes them off. And if it takes it off, and so there's low acetylation, then p53 acts as a transcription factor for p21, and p21 inhibits, so remember these T lines are inhibit the cell cycle. So this is really just a draft. It's kind of messy, but I've captured most of what I'm trying to do. One thing I'll point out is up here, where I have the A, I have it going into the arrow to indicate it's added, and then here it's coming away from the arrow to indicate that it is being taken off.